One of the dominant design principles that Android adheres to is that it's a multitasking operating system. Users can have multiple apps running and can quickly swap between them as needed. My name is Cole McCandless, and in order to make sure that your app is performing well, regardless of what the other apps are doing on the device, it takes a bit of prep work and a few handy APIs. At its core, this has everything to do with the tragedy of the commons. Specifically, apps will act in the interest of their specific situation without consideration for the larger environment. Now, by themselves, this isn't necessarily a big problem, but remember that each running app is taking up a small piece of the device's limited resources. And when those overall resources start running out, the user experience suffers. Each running application has a set of resources that are resident in the device's memory. For example, its state information, graphics resources, and for the most part, all of its allocated heap objects stick around in memory even when the application is in the background. Over time, the device will, as expected, run out of available memory since it's being taken up by other apps, and will need to kill an existing app in order to free up memory for the active application. Remember that the whole reason we keep background application in memory is so that switching to a background app between a foreground app is a pretty fast process. But this doesn't apply for killed background apps. If your app is killed and the user comes back to it, then we got to start from scratch, meaning relaunching the app as though it had never been loaded into memory in the first place, which of course is a much slower operation than just swapping to it from the background. But the good news is that your app doesn't have to be killed. Instead, when memory gets tight, your app can offer up some of its allocated space back to the system in order to avoid the pain of being terminated. To facilitate this ritual sacrifice of memory transfer, Android offers a set of callbacks that will be issued to your app that you need to respond to. But first, let's talk about when things happen when they go horribly wrong. Once all of the other background applications have been killed, in order to save memory, the active application will get an on-low memory callback, which signals that things have gone horrible, and then it should immediately release any in-memory resources to help stabilize the system. If you have things in memory that aren't needed right now, this is the point in which you need to free them. But sadly, this callback only happens after all the background apps have been killed. It would really be nice if instead of simply killing those background applications, they were allowed to collectively release some memory back to the system, which would help move everything along, but also keep them from being killed off. This is the exact reason why the on-trim memory callback was provided with the release of Ice Cream Sandwich. This callback is issued to all running applications and gives them the ability to release memory rather than being killed. This is facilitated by an integer value that's provided to the callback. The trim level that's given to you is a value between 0 and 100, but there are also a handful of values that are defined which you can check against. For example, the trim memory moderate value means that the device is beginning to run low on memory, and it's a great time for your app to start evicting things like your bitmap thumbnail cache. While the trim memory background flag means that some background applications are starting to be killed, and that your app has recently transitioned to being a background app. This is a great time to start freeing up memory that won't be critical if the user comes back to your app really quick. Oh, and if you're comparing against these values, you might want to make sure to use a greater than equal comparison, just in case we add new defined values in the future. And the best part is that in order to help you free up memory from every corner of your app, this callback can be overridden on activity, fragment, service, content provider, and application classes. But in order to produce the best user experience, your app shouldn't just be reactive to tight memory situations, but also proactive depending on the device. The ActivityManager.isLowRamDevice API that was added in KitKat can be used to help detect if your application is running on a device with low memory. Currently, a return value of true typically indicates memory of 512 megabytes or less. This condition should be used by applications to help decide what features to maybe enable or disable depending on whether or not it's going to be a good user experience for these low memory devices. Of course, playing nice with the rest of the system is just the tip of the iceberg, which is why you need to check out the rest of the Android Performance Patterns content. Oh, and don't forget to join our Google Plus community for other great tips from other great developers. So keep calm, profile your code, and always remember, perf matters.